Hello, everyone. In this section, we're going to be covering testing to population proportions. So let's get started. We're going to be making use of the following test statistic. When the samples are independent, simple random samples, the conditions for a binomial distribution are met for both samples, and the sample sizes are large enough to ensure that n1 p1 hat is greater than or equal to 10, n1 1 minus p1 hat, or n1 q1 hat is greater than or equal to 10, n2 p2 hat is greater than or equal to 10, and n2 times 1 minus p2 hat is greater than or equal to 10. The test statistic for a hypothesis test for two population proportions is given by this as following, and note that this is a continuation of our extension of our binomial distribution to our normal distribution using our correction factor. And we see that z equals p1 hat minus p2 hat minus p1 minus p2 over square root p bar times 1 minus p bar times 1 over n1 plus 1 over n2, where p1 hat and p2 hat are the sample proportions. p1 minus p2 is the presumed value of the difference. P bar is a weighted estimate of the common population proportion, x1 plus x2 over n1 plus n2. x1 and x2 are the number of successes that occur in the two samples, and n1 and n2 are the two sample sizes. So again, proportion of 1, proportion of 2, presumed difference here. This is our sum these, and then this is just 1 minus that times 1 over our sample sizes there, okay? So let's go ahead and take a look at some examples here. I'll show you how to do this once by hand and then do the rest via a calculator. Let's get started. And again, making use of our normal distribution using our z test statistic. This one says the mayor's chief of staff thinks that a local newspaper article has changed the community's opinion about the mayor. To test this theory, he finds a poll of the mayor's approval rating that was taken before the article came out and compares it to the mayor's approval rating after the article. Before the article ran in the paper, 480 out of a simple random sample of 1,200 voters thought the mayor was trustworthy. After the article, 550 out of a simple random sample of 1,180 voters thought he was trustworthy. Based on these data, use a 5% level of significance to test the chief of staff's claim that the mayor's approval rating has increased. Okay. So note, we have our proportion for the first, proportion for the second. We're saying it increased, which means that our first proportion would be less than our second proportion. That is to say, my null hypothesis is that there's no difference, of course. And my alternate hypothesis is that P1 is less than P2. Again, note, although it says it increased from P1, so that indicates that it's less than here, okay? So one thing that I do want to note is you need to confirm N1 P1 hat, N1 Q1 hat, N2 P2 hat, and N2 Q2 hat are greater than or equal to 10. Note that these are very, very large samples here with relatively even P and Q. So we'll note that it does apply here, but you should go ahead and double check for all of these. Let's start with P bar. It's going to be x1 plus x2 over n1 plus n2, where these are going to be our successes in our population over our sample size. This is 480 plus 550 over 1,200 plus 1,180. Plugging that into my calculator, 480 plus 550 divided by 1,200 plus 1,180. And we find that it's approximately 0.4327731, and so on. Note that this is an intermediate calculation, so I'm going to include as much as possible. I'm actually just going to directly take it from here. But so now z equals P1 hat. All right, so if I want P1 hat, I need to figure out, well, what is it showing in the sample? So I have 480 over 1200 is going to be P1 hat. P2 hat is then going to be the 550 out of 1180, which I believe is going to look a little less kind. Yeah. And so on. So here, I'm going to go ahead and plug this into my formula. So it's going to be P1 hat minus, and I'm just going to write this in order to save myself some space here, over root P bar. I'm just going to write P bar here to save myself a little bit of space. 1 minus P bar 1 over 1200 plus 1 over 1180. Oh, and note, I do need to subtract the common difference, or the assumed difference between P1 and P2. However, note, we assume that it is going to be 0 because we assume that they're equal. Okay. You should include it, but that's why I decided not to. 0.4 minus this number here divided by square root of this number here times 1 minus this number here times 1 over 1200 plus 1 over 1180. And we find that our z value is approximately negative 3.25. Okay. So now, if we're doing this by hand, we're going to make use of our rejection region. We're noting here that our alpha, our level of confidence we were given, or our level of significance we were given rather, is 0.05. So the z sub alpha here is negative 1.645. We'll note that our test statistic here is going to, if I double check my region, it's going to be in here. So it lies inside my rejection region. So that means we reject our null hypothesis. And therefore, we can conclude that the P1 is less than P2, which is to say that the popularity went up. All right, so that was a lot of work. It wasn't hard, it's just computationally intense. So is there a way that we can do this without needing to do all this hassle? Well, the answer is yes. We just go over to stats, test. I'm going to go down to proportion z test. I'm just going to plug in the values. 480, 1200, 550, 1180. Note that it's P1 is less than P2. Take a look. Whew. P equals 0.00056 blah, blah, blah. So this number here, we'll note, is much, much less than 0.05. So again, we would reject our null hypothesis. Okay, so this is what's going on in the background here, but this will let us know. Okay. Incidentally, it also calculates that test statistic for us, 3.25 for blah, 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 blah. So helps us quite a bit. Let's do another one here. In September, the annual U.S. Surgeon General's call to action was released. It was an initiative aimed at promoting walking and walkable communities. After a campaign push to emphasize call to action in their area, community leaders were curious to know if the campaign worked. They hoped that the proportion of local adults who could identify walking as a way to promote healthy living was different than that of other communities. A year later, a nationwide study of 4,114 adults revealed that 44.8% correctly identified the activity promoted by the U.S. Surgeon General call to action over the previous year. The local group found that out of 121 adults, 65 were able to correctly identify walking as the call to action. Does the evidence support the community's claim that the proportion of local adults who could correctly identify the Surgeon General's call to action was different than the nation? Use a 0.05 level of significance. Okay, so one thing that I do want, well, I guess first things first, I'll just start with our hypotheses here. And we were saying that it's different, so P1 is not equal to P2. Okay, now that that's out of the way, something I want to note here. If I want to go ahead and go to stat test to prop z test and start moving on, well, you might say, aha. Well, if I take a look here, note it requires an x1 and an n1. This gives me this percentage here. So what am I going to need to do? I am going to need to convert this 44.8% of this into an x value here. So I'm going to take 0.448 times 4114. Okay. So that's going to tell me that my x1 is 1843. My x2 was 65, n1 4114, n2 121. Okay. There we go. Stat tests to prop z test, or to proportion z test if you prefer. And then it's just as simple as plugging in our values and noting we're looking at a two-tailed test here. All right. So when we take a look here, we'll note that P equals 0.0519. We'll note that this is greater than 0.05, our level of significance. So we do not reject our null hypothesis, as there is not enough information to conclude that it is different at this level of significance. Okay. And there we go. Hopefully this makes sense to everybody. Be sure to let me know if you have any questions as you're working through these. Otherwise, I will go ahead and see you in the next video.